Take a look at the graph of f of x is equal to sine x. If you observe the graph carefully between 0 and pi, you will see that as x increases from 0 to pi by 2, sine x increases from 0 to 1. That is, the height of the graph increases as we move from 0 to pi by 2 on the x-axis. And as x increases from pi by 2 to pi, sine x decreases from 1 to 0. In other words, the height of the graph decreases as we move from pi by 2 to pi on the x-axis. Now, what do you conclude out of this discussion? Is f of x is equal to sine x an increasing function or a decreasing function? Let's see the analytical definition of an increasing or decreasing function on an interval to answer this question. Let I be an open interval contained in the domain of the real valued function y is equal to f of x. Then, f is said to be an increasing function on interval I if x1 less than x2 in I, which implies that f of x1 is less than or equal to f of x2 for all x1, x2 in I. However, if f of x1 is strictly less than f of x2 for all x1 less than x2 in I, then f is said to be a strictly increasing function. The graph of an increasing function is as shown. The straight line in the graph depicts that at some points, the value of the function remains constant with the increase in the value of x. That is, for some x1 less than x2, we have f of x1 is equal to f of x2. Hence, this function is not strictly increasing. Take a look at the graph of the function f of x is equal to x plus 2. For every value of x, we get a different value for f of x, and as the value of x is increasing from -1 to 2, the value of f of x is increasing from 1 to 4. So, for every x1 less than x2, we have f of x1 less than f of x2. Hence the function f of x is equal to x plus 2 is strictly increasing on the set of real numbers. Now, let us see when a function is said to be decreasing or strictly decreasing on an interval. A function f is said to be a decreasing function on the interval I if x1 less than x2 implies that f of x1 is greater than or equal to f of x2 for all x1, x2 in I, and f is said to be a strictly decreasing function on the interval I if for every x1 less than x2 we have f of x1 greater than f of x2 for all x1, x2 in I. Here is the graph of a decreasing function. The straight line on the graph depicts that with the increase in the value of x, the value of the function remains constant at some points. That is, at a few places, f of x1 is equal to f of x2, though x1 is less than x2. Now, consider the function f of x is equal to minus x plus 2. The graph of the function is as shown. Observe that as the value of x increases from -1 to 2, the value of f of x decreases from 3 to 0. So, as the value of x increases, the value of the function decreases. So, for every x1 less than x2, we have f of x1 is greater than f of x2. Hence, f of x is equal to minus x plus 2 is a strictly decreasing function on the set of real numbers. Now, let's get back to the graph of the sine function and see whether it is a decreasing function or an increasing function. We know that the domain of sine x is the set of real numbers and its range is the closed interval -1 to 1. Let I1 and I2 be two open intervals defined on the set of real numbers as shown. If we consider any 2 points, x1 and x2, between 0 and pi by 2, such that x1 is less than x2, then f of x1 is less than f of x2. This implies sine x is strictly increasing on interval I1. However, if we consider any 2 points, x1 and x2, between pi by 2 and pi, such that x1 is less than x2, then f of x1 is greater than f of x2. This shows that sine x is strictly decreasing on interval I2. This means that sine x is partly increasing and partly decreasing on domain R. Hence, we can conclude that sine x is neither increasing nor decreasing on R.